Today we will be going about 70 minutes, 60 to 70 minutes. We'll see how much time we need to take. Covering 3 chapters, HTTP, which will be the bulk of this. So when someone browses to the web, we want to see what traffic we can capture. We want to look at some of the response codes. Definitely we'll show you a lot more in depth of how HTTP works, because a lot of you just go, oh, okay, well, just type in www.cnn.com and the web page magically appears. So a lot more to it on the background. We'll be covering what happens, how your browser checks to see if the stuff is in cache, the codes that are sent for that. Chapter 24 is FTP. Very simple, very much like HTTP. It's very much you request something and you get a code back and you get some data. Not much to it. It's unencrypted. And the funky thing is it actually uses 2 different ports, so that trips people up sometimes. Especially if you want to use FTP through some certain firewalls, the FTP may not work if you have kind of an ancient firewall. And chapter 25, email, I had you guys download a zip file which contains 2 traces, one for POP and one for SMTP. We'll be looking at that when we do the email portion. And the reason for that is I don't want anyone to be capturing live email. You may be at work. I'm at work, so I can't really do it. And I don't really want to show people personal email stuff. So work on those trace files. That's officially from the book download section. And I did it as a separate download because the trace file downloads, I don't know how many of you have actually downloaded them, but they're about 200, 300 megs each. There's 4 files. It's total 1.5 gigs of trace files. You don't necessarily need to download all of those if you're just practicing with a couple chapters. Okay, before we begin with HTTP, any questions? Anyone have trouble finding the HackPad link or anything like that? Okay, here we go. Well, HTTP. The whole foundation of HTTP is your computer, your browser, actually Firefox, Mozilla, well, now it's Firefox, Chrome, which probably a lot of you are using, or if you're brave, Internet Explorer. It's requesting data. It sends what's called a GET request, G-E-T, GET request, from your computer to the HTTP server. Nowadays, a lot of the HTTP servers out there, I think a majority of them are probably Apache. There's also Nginx, and then there's IIS, which is the Microsoft version. Very cool stuff to play around with. You can install Ubuntu or any type of Linux inside of VMware, start an Apache server, and get a web page. And that's a whole different ball of wax right there in terms of difficulty. We do have some people in routergods that are Red Hat certified engineers, R8CE. That's a hands-on test, and it's pretty nuts from what I hear. So if you want to do that, more than welcome to. Servers respond back with different codes. I have a list of status codes right here. If you click in the HackPad, it brings you to the RFC, and we've got a whole bunch of status codes. The one that you guys are probably most familiar with is the 404 not found status code. You get that when you go to a page on a website that's not there, it doesn't exist. Or it's possible it did exist at one time, but they nuked it, they deleted it. So that does happen as well. What you are looking for normally is code 200 right here. Code 200 is okay. Code 202 is accepted. So 200, anything in the 200s is generally okay. Right? And we'll be looking at that inside of Wireshark. Going back to our HackPad, a couple ways we can filter out HTTP. I gave you a couple options there. We'll be doing this when we do the hands-on section. So http.host double equals, and then you give it the URL. So www.packetlife.net, www.cnn.com, stuff like that. You could filter out HTTP generally with HTTP There's also tcp.port = 80, so filter out by port 80. So the problem with filtering out by HTTP is sometimes not exactly is not going to get you everything. It's not going to give you the TCP handshakes. So that can be very valuable information. Better way to do it is to filter out by port 80. That's going to give you everything. And you can also filter out by the response codes. If you're looking for a particular code like 404, what you can do is you can filter out by http.response.code = and whatever code you want. So if you were looking for 404, you just change that 302 at the end there to 404. And we're going to see in a bit that TCP reassembly that is normally turned on in your Wireshark will mess with how HTTP looks inside of your captures. So you definitely want to turn that off, especially when you're looking at HTTP. So let's take a look. Let's go to Wireshark. We're going to start a capture. Always go to capture options. Scroll down to your network connection. So we've got, let's see, my local area connection right there. And uncheck everything in the bottom right-hand corner. After you uncheck everything, click Start. You'll be capturing packets. Go to your web browser, and we're going to surf to a couple pages. Let's go to CNN.com. So CNN.com's over here. And after CNN.com loads up, hit F5 to load it again. And we might as well go to Reddit.com. Reddit.com. And let's see, let's click on something here. It doesn't really matter what you click, just find something interesting. Here we go. Paramount band showing Team America. Let's click on that. There we go, nice picture. And now stop the capture on your Wireshark. Man, that was a lot of packets. Now the web browsing itself wasn't a lot of packets, but what happened was since you were on this stream at the same time is just a humongous amount of packets. Okay. So how many of you in the room got a decent capture? Probably, I would say anything more than 10,000 packets. Okay, so Ben says 16,000, 23,000. Yeah, mine is significantly more. 114,000. And I'm going to bet that the main reason for that is I'm running the stream. That's okay. Okay, so to filter out HTTP, remember I said that there are two ways of filtering out HTTP. You can type in HTTP. It churns through the packets, and you may get other crap along with that. I definitely did. I got SSDB. I'm getting IPv6. I thought I killed IPv6. Oh, I killed IPv6 on the wireless. I didn't kill it on the wired network. Wonderful. Okay, here we go. That's where our HTTP starts. Now, I already changed my TCP reassembly. Let me change it back to what it was before. There we go. Okay. So as you scroll through, you may notice, you typed in HTTP on the filter. You're scrolling through, you may see stuff like CNN, CNN.com, Get. You'll definitely see the Get requests. right? You'll see, you'll probably see 200 OK, right? So what we can do is we can filter this. Let's look for everything that comes back OK. And it should be pretty easy. If you go back to the response, let's see here, go back to the hackpad, you'll see that I give you the filter http .response.code double equals, and then you put a number there. So we could try it out. We could try out http.response.code double equals 200. So http.response.code double equals 200. Enter. And it's going to churn through everything. And on my particular capture, I came up with, it displayed 424 packets that matched that criteria. Okay. We have someone that says, I cannot see the screen. Does anyone else have a problem seeing the screen? Oh, okay. We have basically everyone else saying they can see the screen. Okay, so if you look down at the status bar down at the bottom, you'll say how many are displayed. If we just kind of click through here, you'll see like you'll say stuff like you're getting back text, you're getting back some JavaScript, maybe an image, JSON, that's JavaScript stuff. So if you take a look, let's go to one that just says some text HTML. So click on there. Doesn't really matter which one you click, just click on any one that has 200 OK and text HTML. As we scroll through here, you'll see that it's encapsulated inside of our frame. Of course, it had to go through Ethernet or wireless to get to you. It's encapsulated inside of IP. It's encapsulated inside of TCP. And then finally, HTTP, right? So you had to go down the layers to finally get to HTTP. If you expand out HTTP, you'll see that it says HTTP 1.1, that's the version. 200 is the response code, and 200 means OK. You can expand that out if you want, but that's not too big of a deal. Server Nginx, remember that's what I told you, Nginx. So it looks like here CNN. Yeah, it looks like CNN is running Nginx, which is very good. It's a Russian-made web server. Very fast, very lean. Now, depending on which one you clicked on, you might get something like a lifetime in seconds, 86,400, a hash, something like that. Or you might see something like I do. It's called last modified. Last modified. Right. So what this means is I go to CNN quite a lot. So I've been to this web page before. And what CNN.com is telling me is this particular page or this particular object was last modified on a certain date, on this date. And this allows my computer, my browser to check whether I need to grab it again. So how many of you in the room, when you clicked on one of your packets that matched 200 OK, you see something like last modified in there, and it gives you a time? You'll find it under, when you click on the HTTP packet, you'll have to expand out Hypertext Transfer Protocol, uncheck it, expand it out, and you'll probably see last modified in there. And you'll also notice on mine, probably on yours, somewhere in there, set cookie, US Rosemead. Yes, when you are going to CNN.com, a cookie is being placed on your computer saying that you browsed to it from a certain city or location in the United States or in the world. And the reason for that is now they can track you. They could also send specific ads, geolocated ads to your computer. Okay, let's go back to our hackpad. So filtering, we filtered out by response code. That's pretty cool. Let's filter out by host, http.host. Let's try it out. So if we do in the filter box http.host = www.cnn.com. And I'll zoom in there for you guys just in case you can't see it. http.host = www.cnn.com, enclosed by quotes. You'll see that you've got your source IP probably on the left-hand side. If you scroll down, yeah, that all looks like my computer going to CNN.com. Got a destination. Ooh, clicked on the wrong one. Okay, got a destination 157, 166, whatever, right? Got a whole bunch of get. And these are basically like JPEGs, GIFs, all that stuff, right? I can change to CNN.com. I just change the CNN portion to Reddit, R-E-D-D-I-T. And we'll zoom in there. And it gives me all the HTTP packets with host reddit.com. And we can kind of look through this. If you expand out the Hypertext Transfer Protocol, once again, you see get HTTP 1.1. That's the version number. Host is www.reddit.com. Got some cookies in there and some other stuff. Now we've been seeing a lot of GET requests. This is you getting information. Here we see something, it's a POST request. POST request is you telling the other guy, you're posting up something, you're giving them some information. So let's see what it's posting. So if you scroll to a packet that looks like this, post/API request promo, something that looks like that, and you open up the packet, you'll see down at the bottom, it'll say HTTP or HTML form URL encoded. And I bet you if we expand that out, that's what you sent up. Oh yeah. And if you didn't realize that these are the subreddit names on Reddit. So videos, today I learned, gadgets, all that stuff. So I guess it's sending up that information. Let's see if there's any difference if we take off the www in front. So just have it as reddit.com instead of www.reddit.com. And you can see right here that it gets very specific. It took it away. Right? It's doing a literal match. It took out all those other packets. Now what I could do, let's see if we can get this to work. http.host, let's say contains reddit.com. Let's see if that works. Contains reddit.com. Okay, that seems to be a little bit more inclusive. So as long as it has reddit.com in it, if it has a www in front, doesn't really matter. You're saying just somewhere in that http.host. And you could try it out with cnn.com as well. Yep, a lot more packets in there. And the reason you may want to do this is it's pretty simple. A lot of times, yeah, the website should start off with www. Oh, that's horrible. All right. Should start off with www, but a lot of times if they're using load balancers, multiple servers, that type of stuff, you'll see stuff like www1, www2, www3, and you get the picture. So if you just are searching for www.cnn.com, you may not catch the traffic coming from those other servers. And we'll get out of there. Let's go back to our hackpad, see what let's see, did the host filtering, some port filtering. We looked a little bit at the status codes. Let's see if we actually got any 404 errors. So http.response.code = 404. Anything there? Yeah, probably nothing because we didn't actually get any errors popping up, so that would make sense. And let's go to HTTP response code, change that back to 200. It'll filter it out. Now this particular filter, let's save it just so we can use it in the future. And we just click here in the bar, click on that save button. That way you don't need to type this in anymore. And you want to give it a name. Let's call it HTTP 200 and click OK. And now you have a button right there. It's very easy. So now whatever you do, let's say you do HTTP host = cnn.com, right? You do that. But you want to get back to HTTP response code 200, just go back here to the button that it created, click that guy, and you'll be back rocking and rolling on that. So usually you'll have a lot of buttons saved. You'll see that I have a button saved for CDP, which is kind of cheesy because all it does is CDP. I could just as easily just type in CDP, but you know, you get the picture. You can make up pretty complicated filters and save them. Okay, so the normal operation here, you're looking for code 200. We're seeing that. Everything's great. Now for the conditional get, what you saw are most of them probably, if you're first-time visitor to cnn.com, those are normal gets. A conditional get is when the browser goes there, you visited 5 minutes before, now you're browsing to it again. You don't need to get the whole thing over again because that would be a waste of bandwidth. If the picture hasn't changed at all in 5 minutes, there's no reason to get that same picture all over again. So that's where your browser has a cache and it keeps objects that are frequently used. That way you don't need to go out to the internet. And to draw this out, it basically works like this. If your computer's here and the web server is out here, normally you're sending a request and the server has to shoot the data back to you. By having a cache inside your computer, some memory, some space on the hard drive to store pictures and stuff like that, you don't need to send that request. You don't need to force the server over here to send information back. So all you need to send is basically, hey, has it been updated? You still send a message to the server, but it's basically, I've got a picture here. Is it still good? Server says, yeah, just use it. Grab it from your cache. Right? And the browsers maintain a cache. You can change the size of that cache if you want. And when you first visit the site, you're going to get back the cache control in seconds. So what this means is, how long is this object good for? How long am I going to allow you to cache it? And when the thing was last modified, and a hash number, hash value, basically to prove that that object is the same. We're not actually comparing the entire file. We're comparing the hash values because it's more efficient to do that. Once you have it in cache, when your client, when your Firefox or your Chrome goes to the website, it's now going to send a query, and it's going to be putting in there if the object has been modified since a certain time. And if it hasn't been modified, it's going to come back with status code 304. 304 is actually a good one. It looks bad, but it's actually good. 304 means hasn't been changed, use it in your cache. Use the one you have in your cache. So let's take a look if we can find that. Let's go back to our filter box here. Change that to 304. So http.response.code equals 304. Hit enter. And look at this. This is all my cache hits. Ooh. I have about 185 packets on that one. Well, exactly 185. You'll notice that they all come from something outside of my computer. It's the servers on the internet going back to me. So these are things that only stuff, it's coming back to me. And 304, not modified. How many of you are able to see this? Response code 304. Yep. Now, how many of you work at a organization, or maybe have worked at an organization that uses some type of proxy like Bluecoat or Squid or something like that? So if you work for any of those, if you work for a big company, chances are you probably have a Bluecoat. And what's happening there is the Bluecoat is buffering a lot of the images and stuff for you. And then what happens there is it's the response, the sources may be coming back from the Bluecoat. And just hang on for a second. The internet on the laptop bombed out. On the other laptop. All right, I'm back on the secondary laptop. Okay, so if we click on any of these that say HTTP response code 304, expand that out, you'll see that you got that not modified, and you'll see that this was last modified November 2009. And I guess they're fine with that. It's fine. It's like, if we click on another one, let's see what we got here. Last modified July 2014. I'm going to guess that one that's last modified 2009. It's probably like a old logo or something like that. Now there are times where there are files that the server never wants you to cache. You always have to get a new one, and that's where you may see something with cache control maximum age 0. That's just like always download a new one. Maybe some type of e-commerce sites or something like that. Okay. You can export a lot of these HTTP objects. Very possible. Very easy. Just file, export objects in HTTP. It'll churn through your system. You save all of them to a file, and then you just manually have to go through them. A better way, actually, of doing that is there's two programs out there. I know I showed them off before. One of them is called Network Miner. It's a network forensics tool that you can pop in PCAP files, and if you get the professional version, the PCAP NG files, and it will carve out the pictures and all the files and stuff like that. It's really awesome. The professional version looks like man, $700. It's kind of pricey there, but it does quite a lot of stuff. You can do it in Wireshark. It's not really the right tool for forensic investigations. If you have to do like timelines, you have to prove that this guy surfed to this site at this time. Pull out all the pictures. There's better tools for that. The other thing you can get is something called Explico. Kind of a weird name there. Xplico, Explico. You can put it in Linux, download it. Let's see, it goes in Ubuntu. You can download it, pop it in. They've got a VirtualBox image as well. They do have a GUI on this. If you bother to install it, it will rip out the WAV files, the MP3 files or whatever from the voice, the SIP. If you happen to capture a voice call, it'll do some nice DNS charts. That's actually pretty cool. Session pages, it'll rip out emails. That's scary. If for some reason the guy's running unencrypted email. The websites. And probably the best thing is all the images in a nice format. You just scroll through there like a album. So rather than exporting it in Wireshark and manually clicking through every damn thing in that folder, going through a lot of false positives, this just makes it so much easier. So that is Explico. And while we're talking about fun stuff to play with Wireshark, when we started this, I recommended to a lot of people that the Datacom, I think it was the Dualcom, sorry about that. I think the Dualcom sniffer. Yeah, this guy right here. All right, we talked about this a couple months ago. It's pretty pricey, $150, $170. I found something much better. It's on one of the YouTube videos that I recently posted. It's the TP-Link 108E switch. It's got port mirroring, so you could do pretty much the exact same thing that this does for $35. and you get a badass switch to go along with it. So if you're looking for a switch, if you're looking to play around with Wireshark, you want to sniff the traffic for educational purposes, of course, look into that TP-Link 108E switch. Can't go wrong with it for 35 bucks. Okay, any questions about HTTP in Wireshark before we move on to FTP? Oh man, I can't click on it inside of Fuse. What a piece of crap. Hold on. Let me check. You're looking for the SG108E. E. It's a managed switch. This one is just a 108 normal, and it's 22 bucks. So the E version is usually runs about $35. Okay, chapter 24, FTP. FTP has two ports that you're concerned with. Most people just think FTP port 21, then you're done. It's not exactly true. You have two ports. One is the command port, all the commands and the requests and stuff go over port 21. Now, of course, FTP, you're sending data, you're sending files, ISOs, sometimes it's really bad stuff. You have two options for that. You can go data over port 20, or you can use a dynamic port. And depending on whether you go active mode or passive mode is what changes that data port. Your command port always goes on port 21, but the data port can change. Now, how many of you remember in the old days mean maybe 5 years ago, where you get a new firewall, you try to start an FTP connection somewhere, and just the FTP connection does not want to start. Just for some reason, it's like, yeah, you're going to the right IP address, you can ping the IP address, it's just FTP will not connect. And the reason for this is some firewalls have a problem with one of the versions of FTP called active FTP. And this is where, okay, the client still initiates the connection to port 21. That's fine. Firewall says that's awesome. But the client then listens on a higher port, on a random port for the data. It's listening for a connection to come in. So as an example here, if we got our computer on the left and the FTP server on the right, we're going out. This is let's call this the command channel. Some random port. And let's call this, on this one, 3000, right? 3000 is going to port 21. Firewall is completely fine with that. No problem. Outgoing connections, firewall will almost always allow through. But what's happening here is your computer is listening for 3001. So it's expecting something coming back, going to port 3001. So from the room, what's the problem with this? What is the potential issue You're going out one port, coming back another. Correct. Stateful firewall. Because it's expecting traffic going back to 3000, and it is getting traffic back to 3000. That's fine. That's on the command channel, but it's getting traffic on port 3001. It never requested anything on port 3001. It's just listening to it. It never sent anything out in the first place. So that's where a firewall will just kill it. It says, what the heck is this? Never asked for this. So that's the problem with active FTP. Now, there are, these days, most firewalls are smart enough to know that, okay, you initiated this on 3000 going to 21. It is probably a safe bet that you are also now listening and expecting stuff coming back on the next higher port. So modern firewalls generally do not have a problem with active FTP, but just in case, it could happen. For those of you guys going for a CCIE, this question can get you, especially when you're configuring it. They tell you configure so you can get FTP, blah blah blah, right? And you just blindly throw in port 21 and call it a day. Well, you actually need to do 20 and 21. Okay, so we have the solution, passive FTP. Passive FTP is where your computer starts both connections, the command channel and the data channel, the C and the D. And since your computer starts and initiates both connections, the firewall will accept that coming back down the line, which is pretty nice. It's pretty cool. So let's start up Wireshark, or actually first let's find an FTP site. Okay, so let's say we want to download some a new Linux distro. Good website to go to is distrowatch.com. Some of you may already know it. Hopefully you guys already know it. distrowatch.com. Go there and it lists practically all the Linux things, Linux variants, flavors that you can download. Right now, Mint is very popular. Mint is actually a pretty good one. So click on Linux Mint, and let's see where we can download this. And so somewhere in here you will see download mirrors, and click on there. And here we go. Let's see if we can find Cinnamon 64-bit. Let's click there. And we have some mirrors here. If you scroll through here, most of these are actually going to be HTTP, I think. Gotta find the FTP one. Oh, let's do this. In the Google search bar, FTP Linux download. There you go, Debian. Always a standby favorite. Okay, so if you search for Debian FTP download, you'll come to a page, and down here it lists like all the servers you can download stuff via FTP and HTTP. Right? These days you could probably get, it is very possible that you can go through much of your IT career without messing with FTP. If you ever decide to do web pages, stuff like that, you'll definitely have to use FTP. But a lot of this stuff's actually done through the HTTP web consoles these days. Okay, so now that we have this page up, let's go to Wireshark. We're going to start a new capture. So start a new live capture. Click on that guy. Continue without saving. So now it's capturing crap. Right? Go back to that website with the FTP link and click on any one that has FTP. It doesn't really matter. So I'm going to go University of Texas. There we go. Let's click on that guy. And just kind of browse through. Go through like a couple folders and a couple folders there. Just kind of browse. And then you'll probably find something like MD5 sum and then click on that guy. Right? And that's it. And then stop Wireshark. And let's take a look at what we have. Now if I filter it out, I can type in FTP. And it gets me a whole bunch of stuff, right? Got about 130 packets in mine. I could also type in FTP-data, and that's the actual data portion of it. Right, so when you type in FTP, this is the command. It might also include the data portion, but I think it's mainly the command portion. Yeah, it is the command portion. If you type in FTP-data, you'll see that the ports change. It's no longer port 21. Right? So FTP and FTP-data. Let's see what happens if we filter it out by port. We could do tcp.port double equals tcp.port double equals 21. You kind of scroll through there. Notice everything is in plain text, passwords, requests, all that good stuff. And tcp.port double equals 20. Let's see if anything comes up there. Nope. And that's because we're using the high port on that one. Let's see, TCP port double equals 21. Get back to that. FTP has its own response codes. 220 is 220, 230, that's all good. And just like HTTP, you could filter out by those codes. And this is ftp.response.code. So let's try it. Let's filter out by, let's see here, 230. So ftp.response.code double equals 230, which is login successful. And I'll scroll in there so you can see it. ftp.response.code double equals 230. Now you may be thinking, now wait a minute, I saw Humphrey just go to that one FTP site. Why am I seeing 5 of these guys? You know, why do I see 5? Well, if you were observing a little bit carefully on the structure I was going to, how many subdirectories did I go through? I went into the main FTP site, and then how many levels down did I go? How many folders did I click on? Well, let's think about this. We see 5 packets on my screen. 5 packets saying I logged in successfully. Most likely that first guy right there was the initial FTP site. And then I remember I double clicked somewhere, so that was the second packet there. I went in deeper, went in another place, and I went in another place. Right? So it's checking on each folder level that I go down and up. So FTP is pretty interesting to look at. Not too much to it. You can click on this list here of response codes. Let's click on that. 200 is usually pretty good. So let's see here. 200 action has been successfully completed. 212 is directory status. Let's see if we have any for 212. Oh, nothing for 212 on my screen. 225 data connection open, but no transfers in progress. Let's do 225. Anything there? Nope. Oh, let's do this. What we can do is just filter for anything that has FTP response code. So ftp.response.code with nothing after it gives you all the ones that have response codes. So you see like 230, 200, 550, login successful, all this good stuff. Okay. Questions about FTP. Main thing to remember is there's the separate command and data channel. There's the active and passive. And knowing some of the most common response codes is probably going to be very useful. Now, of course, if your company doesn't have an FTP server, you're running Wireshark, you're sniffing on the edge or something, and you're seeing FTP traffic, that might be a cause of concern. You know that there's not supposed to be FTP inside your network, but you're seeing it. Could be someone grabbing a file from the inside. Could be someone set up a bot and it's FTPing back. That would be kind of a stupid bot, basically alarm bells ringing. These days you would hide that data inside of something else. But, yeah, just something to look at. All right, moving right along. Let's see, we're looking at almost 60 minutes, so we got a little bit of time. Email, oh yeah, POP and POP3. Now, if you've been around for a while in computers, you definitely played with POP email way back when, and this was generally very big in the dial-up days. Today, you just go online, you have a constantly on connection. It goes through port 80. It's all good. But back in the days, what would happen is you would turn on your computer, you dial in, get a list of emails, download them, and then disconnect. And the reason for that is you were charged per minute, per hour, whatever it was. CompuServe, all those services, it could get expensive if you stayed logged in. There was also stuff like Earthlink and stuff like that. So there were various email programs out there that let you pop your email. One of them was, I think it was Outlook Express. Outlook Express was one. There was also another popular one called, what was it called? Eudora, I think it was. Yeah, it was Eudora. And that lets you pop your email. So filtering out POP email is actually very easy. POP is how you grab the email. There's SMTP, which is how you send the email. The port for SMTP is port 25, and the port for POP is 110, both TCP. And you can filter very easily by either doing it by the port, tcp.port, or by the word POP or SMTP. All right. And so we're going to look at one of those traces that I told you to download. Let's close down Wireshark. And let's go directly to that trace. And let's take a look at the one called pop-normal. Pop-normal, and double click on it. This is pop-normal, 37 packets, so this is a easy one to play with. So this one you can see that we have the TCP SYN, SYNAC, ACK at the top. We've got POP following after that. If you had filter just by POP, if you just said POP, you wouldn't have gotten that SYN and ACK because you're just looking at POP. But if you have filtered by TCP.port double equals 110, then you would have gotten the whole communication. So that's why, yeah, filtering by POP is all good, but a lot of times you want to see the SYN-ACK as well. So looking at this, if you go down to packet number 4, expand it out a bit, post office protocol, expand it out again. Response indicator OK. Everything's good. Server's ready for you. And if you click on number 5, the user information is sent across. Number 6, server is basically saying everything's good. Give you the password. Notice this is all unencrypted. It's freaking dangerous, right? You're seeing everything. This is like the telnet of email. You can see everything. Probably another good reason why not used that much anymore. Back in the old days, well, it's still used, but people would set up Apache servers. They run something like SendMail is a big one. QMail is kind of the other one for email servers. It was actually pretty awesome to get an email server running. Right. So what happens here is you connect the server says you're good, you open up your mailbox, and the mailbox basically says, oh, by the way, you've got one unread email. Would you like to download it? And then your client starts downloading it. And of course, since it's in awesome unencrypted, you can read the damn thing if you want. It's not a big deal. As far as SMTP is concerned, let's close this capture out and double click on the capture that says smtp.normal. This is when you want to send an email. Pretty much the same thing. You see it's unencrypted, pretty scary. It shows you the server, and when you see stuff like MX is mailbox. When you see stuff in DNS called, they say MX record is a mailbox record. That's for DNS. And it tells the internet how you want to receive email, the server that should be receiving email. And we can filter this out, SMTP. Someone's got a mic on. So SMTP there. We could also do TCP.port double equals 25. Okay. So email's usually pretty easy. It's unencrypted. If you're looking for particular people, like for some reason, if you're concerned about a person sending to a particular person, what you probably could do is make a filter. Like let's say packet number 11 here. If you have it filtered out on TCP.port double equals 25, here you could say recipient 2. I could expand out SMTP, Simple Mail Transfer Protocol, and I could probably make a filter for that. As I right click, apply for filter, selected, and then basically I could change this guy to match particular names. So I may want to something like this. ST command line, I'll say contains TMZ Something like that. SMTP command line contains tmz.com. Why would I do this filter? What would be my reasoning behind doing something like this? Looking for all SMTP traffic containing tmz.com. Well, the reason for filtering out everything containing tmz.com is I want to make sure I catch whoever tries to send out an email to TMZ with some juicy information or something like that. So that would be a thing to go. Now, this is not going to catch. This is just going to catch the stupid people, because the smart guy is going to do this offsite. The smart guy is going to send through Gmail, which is encrypted. So it would be completely dumb to use unencrypted SMTP if you were going to do this. Right? But sometimes people are stupid. Or they use their phone that goes to the cellular network, and you're not going to see it on a normal Wireshark capture. Okay, any questions about email, POP, and SMTP?